Hello everyone, this is Ruhollah Jahan Mahin and I'm presenting a recent paper with the title of Human-Robot Interaction in Manufacturing, a survey of human behavior modeling with Dr. Masood, Dr. Rikli, and Dr. Jurik. Uh, we are presenting this paper in Flexible Automation and Intelligent Manufacturing International Conference, which is held in Wayne State University. First of all, let's start with Industry Revolution. Industry 1.0 evolved through the development of mechanical production infrastructures for water and steam-powered machines, and there was a massive gain in the economy as production capacity increased. Industry 2.0 evolved with the concepts of electric power and assembly line production. Industry 2.0 focused primarily on mass production and distribution of workloads, which increased the productivity of manufacturing companies. Industry 3.0 evolved with the concepts of electronics, automation, and also information technologies. And also Industry 4.0 evolved with the concept of smart manufacturing, digitalization, and also cyber physical systems for the future. And now we are in the era of Industry 5.0, which is a future evolution designed to use the creativity of human experts working together with efficient, intelligent, and accurate machines to achieve mass personalization. Industry 4.0 and Industry 5.0 have different characteristics. In Industry 4.0, the main principle is to make the manufacturing industry smart by interconnecting machines and devices that can control each other. In Industry 4.0, we have mass production because we have large scale production in Industry 4.0. In Industry 4.0, by integrating several technologies such as artificial intelligence, Internet of Things, cloud computing, cyber physical systems, and also cognitive computing, we have a smart supply chain. Industry 4.0 focuses on improving mass productivity and performance through the provision of intelligence between devices and applications using machine learning. The last feature of Industry 4.0 is removal of manpower. In Industry 4.0, the main priority is process automation by reducing the intervention of humans in the manufacturing process. On the other hand, in Industry 5.0, uh, Industry 5.0 primarily designed to enhance customer satisfaction, so customers can prefer personalized and customized products according to their tastes and needs. By using market knowledge and a virtual corporation to exploit profitable opportunities in the marketplace, we have responsive supply chain. Industry 5.0 will significantly increase manufacturing efficiency and create versatility between humans and machines. In Industry 5.0, the majority of the production process will be automated in collaboration with highly equipped specialists. And the last interesting feature of Industry 5.0 is the provision of greener solutions compared to the existing industrial transformations. Let's talk about human-robot interaction. We can categorize human-robot interaction into three parts of uh, coexistence, cooperation, and collaboration. In coexistence scenarios, human and robot worked on unrelated tasks, so they don't have a shared space and they don't have any contact, and also context awareness is impossible. But in cooperation and collaboration scenarios, human and robot worked in a shared space. In cooperation scenarios, human and robot worked on a sequential tasks, so uh, context awareness is possible, but contact is minimal and they can accept any level of contact. In collaboration scenarios, human and robot worked in a shared space and worked on a same task, so the context awareness is desired and they have contact. So for this paper, we the goal of this paper is provide a detailed review of human-robot interaction, focusing on human behavior and human decision making in manufacturing. We collected paper from 2000 to 2021 based on the mentioned keywords. So first of all, we found about 400 papers, and because of unrelated scope, language, and application, we reduced the number of papers to 60. So for this paper, we reviewed only about 60 papers. So we categorized our papers based on the robot-centered HRI and human-centered HRI. Human-centered HRI investigates issues such as the design and usability of proper interaction interfaces. Robot-centered HRI focuses on algorithms, engineering innovations, and other computational approaches to improve the overall performance of the interaction. After that, for social and industrial robots in both human-centered and robot-centered HRI, we categorize papers into three parts of factorial design uh, that focuses on identifying factors that impact the HRI from a human behavior perspective, predictive analytics that focus on better forecasting human behavior in HRI, and also control structures that evolve on the ideas of better controlling robots considering humans' behavior. So let's talk about the results of our paper, and I will show some interesting results and tables and also graphs based on our paper. Based on the trends in the literature, uh, in terms of the trends of sensor utilization, most researchers, about 48% of the published works, relied on vision sensors. This can be attributed to versatility, reusability, and also affordability of vision sensors, especially cameras. Vision sensors are followed by distance, about 23%, audition, tactile, force, motion, and psychological sensors. In terms of the trends of uh, research perspective, literature is more concentrated on robot-centered HRI, about 68% of papers. In terms of the trends of focus area, control structure is the leading focus area, about 57%. followed by the factorial analysis 43%, and predictive analytics 21%. This can be justified as 68% of the reviewed papers approaches this research problem from the robot-centered perspective. And finally, in terms of the trends of validation technique, as displayed in this figure, 60% of the reviewed papers relied on a real robotic environment for validation of their findings. So based on the distribution of the literature across the years, we have different graphs. In terms of the sensor utilization, which demonstrates a reduction in reliance on vision sensors over the years. This reduction can be a result of the increase in sensor production cost over the last few years. In terms of research perspective, the dominance of robot-centered HRI seems to be the leading perspective in human behavior modeling in HRI. In terms of focus area, while there has been as increase in research focused in factorial analysis, no certain conclusions could be reported on predictive analytics and control structures. And in terms of validation techniques, this graph displays a decrease in using actual robots for validation purposes. This decrease can be caused by the advancement made in physics-based simulation modeling and emergence of game engines in manufacturing. So here we have a summary of the surveyed papers. For example, in this paper, based on the research perspective, researchers focused on human-centered HRI. Also, they use control structures for focus area, and they focused on manufacturing settings. They used distance sensor for their analysis, and also for the validation technique, they used simulated robots and real robots at the same time. In the other paper, researchers used human-centered and robot-centered HRI at the same time in their paper. Also, they focused on factorial analysis and predictive analytics at the same time for the focus area. Their application was for social robots, and also they used vision sensors, and they validated their results based on real robots. Now we can talk about limitations and research opportunities based on what we found in surveyed papers. In terms of limitation, some researchers validated their proposed approaches through simplistic simulation instead of real experiments. And I think this is because of the cost of real robots. But on the bright side, simulated robots have a powerful engine in these days, and researchers can use them. Uh, some papers had a lack of generality, such as case-specific definitions of human cognitive behavior, emotional expressions without considering personality traces, temporally fixed human behavior modeling, and also conducting experiments limited to a specific robots. And also computational uh, efficiency, where exponential growth computational aspects of the modeling restrict the performance of the proposed approaches or led to over simplification and loss of information. So based on the limitations that I present in the previous slide, uh, we can talk about some opportunities that researchers can use them for their current or future research. The existing works focus on developing high performance and accurate solutions without studying the computational implementation and also maintenance costs. Better understanding uh, some concepts such as timing in interaction, physical, environmental, and communication modes. Newer topics such as threaded control, shared control, or hybrid control, which are the variations of sensor-based control, and also social effects. The use of lag constraints has not been sufficiently explored when multiple robots are integrated to perform a specific task while collaborating with different humans. Finally, we can summarize our findings here. First of all, robots should become context-aware and capable of learning about human behavior, such as cognitive modeling. Moreover, in this survey paper on human behavior in HRI, the goal is to illustrate the points of contact between robotics and human behavior. And the approach for classifying recent papers in this study is based on two categories of human-centered and robot-centered interaction. Thanks for your time, and I will be happy to answer any questions. You can send me an email and I will answer your questions. Thank you.